Well, good day, everyone. Thank you for taking the time to listen on another informational session on plant disease. My name is Andrew Friskop. I am an NDSU Extension Plant Pathologist at North Dakota State University, and my role and responsibility is to provide the applied research and extension messaging for small grains and corn in my state. Today, I get to talk about a topic that I've been spending the last 6 years on, both from an extension outreach aspect, but also from a research aspect, and this is Ergot. And today, the title of the presentation is we came up with is the Ergot Challenge, Management in Wheat and Agricultural Impacts. So I have a couple goals today from this. So we have a really big, broad terminology from a title aspect. But my goals for the audience today is one, become an ergot identification expert. You're going to see a lot of photos, and this one is pretty simple to identify, but I'm going to take you through some of the photos that I have received over the years. The other thing I want you to recognize is the awareness of factors that increase ergot risk. We're going to dive into that a little bit more. I'm going to specifically spell out a couple that I have seen, that I've had conversations with, that when we've seen some higher levels or higher frequency of ergot. And then finally, going to spend most of the presentation on the management and implications. Now, this is going to be a blend of what has been recommended for the hundreds of years, honestly, and then also some of the new insights that we've been exploring and are, would say, revisiting some of the recommendations we have, at least in the Northern Great Plains. All right, let's talk about the pathogen and the disease first. So disease known as ergot is caused by the fungus Claviceps purpurea. The most recognizable feature and the sign of this pathogen are these black to purple sclerotia. We call them ergot bodies. What they more or less are is this hardened mycelial mass of fungal growth, and those will either fall to the soil surface, may go into the end of sale in the grain lot with the small grains. And what we have a problem with is these sclerotia contain very high levels of alkaloids. And we don't think of this disease really from a yield loss aspect, but we're really concerned is the quality. Now, these alkaloids, what they can cause is vasoconstriction. So think of it as cutting off the blood flow to the extremities, to the fingers, to the legs. I'm going to mention some of the historical documentations of this. When we think about it in animals, we'll refer to it as ergotism, when you might see the ears start to slough off, the tails, the hooves. So the same type of effect that it has a vasoconstriction. It can also lead to vomiting as well, and as well as convulsions. And we know a very long history that these alkaloids are the problem, is why we have to worry about it. When it comes to identification, these next couple photos are going to take you through what it looks for. So in this first one, we have a 2-row barley spike. We have what I call the early stages of sclerotia formation. Still looks soft, still looks mushy in, as far as a non-scientific term. But this mycelial mass will harden over time. And this is kind of a good way to look at it as far as on the early stages. As it becomes more advanced, you get the hardened black sclerotia with that. And then on the photo on your right-hand side, we also have the honeydew stage. And I'm going to explain that here a little bit more as we move through it. When you look at the end of the season, it's probably the most recognizable. When we're looking for those amber waves of grain that we often see, you might see these black sclerotia really stick out, and they stick out like a sore thumb. And those are some of the more diagnostic features. Oftentimes, when we look for this disease, we see it on field edges. I'll explain that a little bit too. And in other cases, you may see it in more prevalent across the field, and that is where it becomes much more problematic. It has a very large host range. Here are some photos of what it looks like on winter rye, 2-row spring barley, hard red winter wheat. The same concept holds through, is that you're looking for these black, hard sclerotia bodies that more or less take the shape of the floret it's sitting in. And a good way of looking at this is across a variety of hosts, from grassy weeds to some of the agronomic crops. So moving left to right, we have quackgrass, smooth brome, hard red winter wheat, hard red spring wheat. We have a triticale, and then we have some barley samples as well. So what is this looking like? You see the same sign, hard black sclerotia. And as I mentioned that it takes the shape of those floret structures, here's a close-up of what this looks like. On the far left-hand side, we have some sclerotia that I picked from smooth brome, some that I collected from rye in the middle, and some that I collected from spring wheat. So you're going to see the shape differences, but it has everything to do with how well it's staying enclosed in that floret. Okay, the other thing that we can look for is ergot in the harvested grain sample. And this is often referred to as far as terms of looking like rat droppings, maybe first a misidentification of it, mouse droppings. But really, what you can look for is some of the features. You're still going to see the crease of what you would see in a kernel on these ergot sclerotia. And you're still going to find it in a grain lot. They're still going to stick out and be fairly noticeable. The reason why I'm showing this photo is that when it comes to an agronomic implication, is we have very strict thresholds on the amount of ergot that we can have in our sampled lot. How they do this is a proportion of weight of sclerotia to the total grain weight. And our threshold for wheat, as an example, is 0.05%. To weigh to translate that, that's more or less 10 ergot bodies in a kilogram of grain, or 2.2 pounds of seed. It is not a lot to be able to be classified as ergoty. Now, if you move to a different small grain market, you're going to see that those thresholds will differ. Rye has a more forgiving because it is more susceptible, but the big concept here is that it is a very strict threshold, and the reason why has to do with the alkaloids that are being contained in those ergot bodies. This is what it looks like from a disease triangle perspective. So let's put it all together. We talked about what it looked like. We talked about the host range. One thing that we didn't cover yet is the weather. So we're gonna touch on that in the disease triangle. As a reminder, grass hosts are the host, and we have a lot of them. In a paper that was produced by Alderman et al. In North Dakota, we have 59 reported grass hosts. And that's the weedy grass species, that's the agronomic crops. There are a lot of crops that are susceptible to this pathogen. When it comes to the environmental parameters, it's called a cool, wet disease. And what that translates into is 60 to 80 degrees, which pretty wide window as far as the temperature range. Rain and lawn dew periods and prolonged flowering periods. Okay, so some of those factors, sometimes the cooler it is, and the more wet or rain that we have in a small grain crop, the longer it takes to pollinate and produce flowering. The pathogen itself, it has about a 1-year shelf life. So if you want to compare and contrast this to white mold sclerotia, white mold is much more melanized, much more conditioned. Ergot doesn't have that. It only lasts about a year. And part of that, it's not as melanized. It has a very high sugar content, which attracts fungal microbes. It attracts insects. And then more or less, you can see feeding injury on it. It decomposes after about a year. So if you want to look at some aspect in this management that we'll talk about later, is this is a kind of a win when it comes to management, knowing that it doesn't last in the soil all that long. What this looks like in disease development in real time, what I'm going to do is take you through the infection process. So generally speaking, when I think about ergot, it often starts with our weedy grass host. And here we have smooth brome on the field edges. You can see some of the ergot bodies protruding from those floret structures, and they fall to the ground. It can also fall to the ground if you're harvesting a wheat, barley, durum, rye crop. We have these ergot bodies that sit on the soil. And the following spring, I guess, when we look at this, there's two things that need to activate it. One, it does need that kind of cold stretch. Think of it like a vernalization process to start the germination of these ergot sclerotia. On here, we have some ergot bodies sitting on the soil. Once we get the moisture, once we have a successful vernalization aspect or a condition factor, it will germinate. And when it germinates, it produces these mushroom structures. We think of them as stromal stalks with capitulas on top, but how I refer to them is think of these mushrooms coming from these ergot sclerotia. So now the amount of these mushrooms that a sclerotia will produce really has everything to do with how big that ergot sclerotia is, because you think of this as a food reserve, it only can produce so many mushroom structures to be able to be able to support the livelihood of these structures. Now, once these structures are formed, they start releasing spores. Now, these could be releasing spores all year or during a fraction, a month, but really, when it comes to wheat, the most important time is at that pollination process. So pollination before we actually see the flowers. In most of the spring wheat, that pollination is occurring at the half head, full head growth stage. And what the target is the female floral part. And here we have the stigma, featherly structures. And how I look at this, and here's those risk factors, is that if pollen beats the ergot spores to the female floral structure, you're going to get a kernel. If the ergot pathogen beats the pollen, you're going to get an ergot sclerotia. Okay, so it's almost like a battle for the same structure of that floral part. Now, there are some factors that are going to influence this. Now, depending on if your host is a self crop, meaning that in our wheat varieties and our barley, we have selfing right occurring in the spike itself, or if you have an outcross. So in an outcross, the pollen source is coming from somewhere else. What we see with rye, and is one of the factors why rye is more susceptible, because that vulnerable period of pollination or infection, however you want to look at it, has been extended. Some of the other factors that can increase your ergot risk is anything that can damage the floral parts. And this could be heat, could be chemical, it can be freeze, anything that can damage that female stigma that doesn't allow it to receive the pollen is going to increase your risk for ergot. Once you have successful infection, in this case, we have the honeydew phase. Now, honeydew is more or less of these sap droplets that are full of sugar and spores. That's what they are. Now, they can range in color from a more opaque, milky white type of honeydew to a more golden brown. Okay, so when you see this in the field, this is the predisposing factor before the ergot sclerotia is going to form. Now, this is the part where you can have secondary spread of the pathogen. As I mentioned before, it is full of sugar and spores. And the one thing that is attracted to sugar are insects. This can be ranging from flea beetles to flies to gnats to mosquitoes. Most of the time, it's going to be some type of winged insect that's going to be attracted and feed on the sap and carry those spores to another potential host. So when we look at this in a field setting, when I mentioned that we see this on field edges, what may happen is you have that infection happening on the brome grass. You have insects, winged insects feeding on the honeydew, and then they fly into the wheat, the barley, the durum, the rye field, and they're carrying those spores with it. One thing we also know with our weedy grass hosts is they tend to head and flower quicker than our agronomic crops. So you have that window of opportunity where it's available for the pathogen and it's available for the insects, and they're able to transfer those spores into a field. And sometimes you can actually see a gradient from where that feeding or that transfer of the pathogen occurs. So sometimes I get to ask this question, is insects being a carrier? And this is the best way that I can relate to it. Once you have the infection occurring, this is where the development of the ergot bodies. And as I mentioned before, the same features exist. And this is what we deal with. Okay, now let's take a step back. We did a deep dive into the pathogen and what it looks like, some of the factors that increase your risk. But why does this sound so familiar? And I'm not going to spend a lot of time on it, but for those that have taken introduction to plant pathology or maybe have remembered a plant disease, ergot often comes up in conversations. And this is what I call some quick history flashcards of where ergot's been referenced. One of the earliest records of ergot is a Syrian tablet in 600 BC. There's mentioning of these noxious pustules on grain seeds that affected Julius Caesar's army. And when you think about this, it's really if rye or a susceptible small grain crop is used as a food source, this could potentially impact some of these mentionings in history. So we can't always just prove as far as ergot being the cause of this, but there's a pretty heavy association with it. If you want to go back to 1093, St. Anthony's fire, the religious order was formed for disease known as holy fire. And this was the sufferers that would have tingling, sensation, convulsions, losing of limbs. And a lot of this has been related back to a food choice, which would have been rye at the time, which we know is quite susceptible. One that is often most referenced is the Salem witchcraft trials in the late 1600s. It is possible that the victims may have ingested ergot because of the staple food source of rye. And during that same time with the Salem witchcraft trials, we had this period of weather with cool and wet conditions. So here we're starting to do that disease triangle, knowing that we have a susceptible host and we have the conditions. The assumption is that we also had the pathogen present in the Northeast at that time. Moving through history, the Great Fear in 1789, mass hysteria in French peasants that was potentially blamed on ergot, the demographic depression between the French and the English, and one reason because of that is they think the primary food source of rye versus wheat may have influenced the amount of ergot probability. Now, taking you into the 1900s, one that does get brought up still to this day with some of the growers I talked to is the use of ergot in the pharmaceutical industry. We know that it's a vasoconstrictor, and we know that in some cases it was being used in the pharmaceutical industry to help with bleeding, help with migraines, and because of that, there's actually what I call the one of the centers of ergot production, which is in Dassel, Minnesota. And they actually have an ergot museum there where they talked about the importance of the ergot industry throughout the 1940s and 70s, where they'd collect ergot, sell it to the pharmaceutical industries. Now, this industry is no longer there. You're able to synthetically produce these products much more efficient. But again, it has this running narrative throughout history. Now I'm going to take you to what I call my narrative of what I've been dealing with. And this is going to take you back to about 2018 when I started getting some of these ergot concerns. The first couple slides I'm going to show you is just general prevalence of ergot, both in Canada, but also in North Dakota. And this is some of these survey efforts that I was able to find. But Walkvik did mention in his paper in 2022 that when they do these large surveys of looking at their durum wheat and bread wheat, they're looking for ergot. And if you want to look at this over time, they're able to track it all the way back to 1995, 2020. This is an unbelievable source of information. They started noticing a trend in the throughout Canada that they were starting to see more ergot. And my landmark was 2018, but if you look in the last 2015 to 2020, you see that ergot levels have moved around, have been a little bit dynamic in nature, and this is pretty typical what we see with ergot. Some years we see some more than others. Oftentimes it's tough to pinpoint it exactly why, but again, if we use that disease triangle, it may have everything to do with the right conditions, with the right amount of spores on susceptible hosts. If you want to look at what it has been in North Dakota since 2010, here through our IPM survey effort where we hire scouts to survey fields in North Dakota, what this data is representing is the frequency of fields that we found at least one plant with ergot. So it's not severity or incidence, it's just if we found ergot in the field. And I'm targeting what 2018 is that when I started these problems, when I started addressing these problems in North Dakota, it's not that we've had a huge rise in ergot in this state. It may have everything to do with some of these localized incidences where we can help explain. But if you want to look at this generally, there's two common themes that we know ergot is common. We have plenty of hosts. We're always going to have ergot. And we're going to see these fluctuations in fields having it. Now, in most cases, it's only going to be an edge effect. I've had conversations where it's been worse than that, but by far and large, we notice it in the field, but it's rarely a concern. So in the 2018, this is where it started. So some of the Reuters articles that came out was some of the fear of some of the ergot that was found in the early crop or the early harvesting of the crop. As we went through the growing season, we saw media talking about the elephant in the room with ergot. And then NDSU extension coming out about it's not just maybe just in our wheat, but also, got to pay attention to anything that's being used as a food source for animals. And what it more or less resulted in is that we still had a very good crop in 2018, but we did have some areas that struggled with some of the ergot. And that was a core extension mission for me, was to look at where were these problems at? Could we help explain some of these problems? And then finally, doing some of the research to help with the management. So our approach to that is we worked with our county agents. We're lucky where we have a county agent in every county in North Dakota. I had a conference call to present what I call baseline understanding of ergot information or commonly asked questions. And then I asked the agents that were willing to survey some of the elevator managers just to give us an idea how important ergot was for them this year. Now, mass, what I call effort. We had 8 elevators partake, but I think just gives us a pretty good representation of what happened in 2018. The most impacted elevators indicated 20% of the grain loads were discounted at the time at 35 cents a bushel, which is a pretty steep discount, indicating that you're going to start prompting fears of bringing even in any more grain, which means they're going to have to store it. And in 2018, wheat was going to be the cash crop, and soybeans were going to be the one that was binned. So now we started creating some storage issues because of it as well. As mentioned, that some of these trucks that weren't bringing them in, about 100,000 bushels at one elevator were estimated, not brought in because they're still trying to figure out where the ergot was coming from as far as trying to produce the highest quality crop we can for North Dakota. We had a wide range of ergot levels. I mentioned before that the threshold for ergot was 0.05%. Some of the samples coming in were at 0.5%, which is 10 times higher. And there was even a report of 5.28%. Now, this could have been some screenings or cleaning that was brought in. But the idea is that, when we look at these thresholds, yes, we have to look at them. And we know we have a very strict threshold. And it's kind of a vigilant type of effort when it looks out across elevators. Because of this, we started working again with our extension agents and extension events, brought in the North Dakota Wheat Commission, and where the bubble chart or the circles that we have on the state of North Dakota there, that was all the areas that I was giving talks about ergot, and more or less working through some of these situations. This is probably my favorite part of this whole effort is you get into a room like this, and at the time, my PhD student, Dr. Leanne Lux, who is now at North Carolina State University, this was a very common setting. We have these hands-on demonstrations, break them up into groups, and these were more or less the 4 questions that kept on getting brought up. Can I spray anything? What about variety resistance? Why did I see it this year, but I haven't seen it in 5 years? What can I do for next year? And this is really what I call is the foundation of that nice blend of taking those grower questions, crop consultant questions, and to take them to the research avenue. So this is what leads them to probably the most important thing is management options. Now, the first one I will mention, I didn't update any research on this, is we have tillage and crop rotation. So this has everything to do with what we know about ergot. So as I mentioned previously, it only has about a 1-year shelf life in the soil, meaning that it's viable for 1 year. The reason is you have insects and fungal microbes eat on these ergot scrotia, they break them down. The other thing with tillage is that when these mushrooms are being produced on the ergot bodies, they can only grow max out to about 3/4 of an inch. And so if you're able to get those ergot into the soil or incorporated into the soil, those mushroom or that primary inoculum source is not able to get above the soil surface. So that's more of the concept and kind of the seeing as believing aspect of, yes, these can work. Now, it doesn't help your field edges problem, but it does within a field. If you had an ergoty wheat field or had higher levels of ergot than you would like, crop rotation and tillage can help. Doesn't help if you're doing no-till, but crop rotation would be your biggest friend. Moving to the grassy weeds, it is really important, and I do get a call every June, probably first week of June, is starting to see grassy weed hosts next to my wheat field on the field edge. What should I do? Mow them, cut them, terminate them, whatever you want to do. Control those grassy weeds from heading to allow that secondary transfer of the pathogen via insects, via wind, from the weedy grass host into the field. We can also have harvest strategies. So this is more of right before you harvest, look on the edges of your wheat field. If you start to see some ergot developing on that, mark how far in the field it is. And this actually does work. What I'm showing you here is actually an example of what a grower gave me. Is he had a grassy row ditch on 2 sides of the field, corn on one side and soybeans on the other. When he walked into that field, he noticed that his ergot problems were on the field edge bordering the grassy weeds. Makes sense. The decision he made was harvested that, at first pass or opening up the field and kept it separate. Because of the strict thresholds, avoiding that commingling of grain is so important when it comes to ergot. And he was able to harvest it, keep separate, and had a pretty good success. The other another management tool that you can have in the post-harvest sphere is cleaning seed lots. Now, when you think about cleaning, by far the most the most effective cleaning source we have are color sorters. They're able to remove pretty much all ergot bodies in a grain lot. Now, in North Dakota, we don't have the access to color sorters. Not widely available. It can be expensive, and they take quite a long time. What we typically see are these gravity density, air-assisted type of cleaners like we're seeing here. And the idea is you're able to remove ergot bodies. You may not remove all of them, but if you do have an ergoty seed lot, you're able to remove most of them in the screenings. And it does work. One of the growers, one of the seedsmen that I work with closely in north central North Dakota, he's able to show me pictures of how much success he is able to remove ergot. He never guarantees all of it, but this does work, and it can reduce the amount of ergot bodies. The two tools that I explored, though, was looking at variety resistance with a team. So it's not just me, but my team, that graduate students and research specialists, and then fungicide trials. And that's what I'm going to end this presentation on today. So when we looked at ergot resistance in hardwood springwheat, the only other work was done up in Canada, different varieties, different market specs. But if you want to look at North Dakota specifically, I was not able to recover any information where there has ever been a robust ergot effort for variety resistance. The only mentioning of it was in a very old spring wheat variety back in the late 60s. It was Waldron wheat. And the reason why it got pulled from the market is because of ergot susceptibility. Now, I want you to remember Waldron wheat because it is going to be made reference here in a bit. What we did is I hired an excellent graduate student, Leanne Lux, and with funding from the Wheat Commission, we looked at resistance in 21 spring wheat varieties. The things that we looked at is ergot incidence, amount of ergot bodies or ergot weight that we pulled from these varieties, and then the ergot sclerotium characteristics, size, shape, area, diameter, and we're going to dive into that here in a little bit. So did this greenhouse experiment, got it published in Plant Disease. What did we look for? So when we made the initial infection of the ergot pathogen onto the female flower part, Leanne made some observations. The three observations that were made are in every inoculated floret was an ergot body produced, was a kernel produced, or did it abort, meaning that we did not have a kernel and we didn't have an ergot body. On the bottom axis, we have the spring wheat varieties that we tested. On the vertical axis is the percentage of the time that we saw one of these observations. So on the very far left is Waldron, as I mentioned, was removed from the market in the late 60s because of ergot. The first bars I'm going to show you is the propensity of ergot being produced or ergot incidence when infection occurred. As you will notice is that the Waldron wheat was the most susceptible. And as you move left to right, there's nothing immune, but there were what we call some pretty subtle differences in the amount of ergot that was produced. When you look at the kernel characteristics, they're kind of all over the board. There really isn't an association between ergot incidence and kernel incidence, but there are some what I call different variety responses. So genetically, we know there's something occurring. We need more testing to kind of help filter out what this looks like. And then the other aspect is looking at the amount of florets that just remain aborted. Again, you're going to see it makes up the rest of this 100% proportion. So this chart shows you that when we affect these spring wheat varieties, that we know that ergot is produced. We know kernels can still be produced. And then the other thing is that we know that there's some abortion occurring as far as not being able to produce either. So looking at this data is a kind of a good demonstration of what the host reaction is. But this led to a next question as we were working through this problem. And this all started with a North Dakota Wheat Commission board member. He made the comment, and cleans a lot of seed, that the most difficult ergot bodies to remove from a seed lot are the ones that resemble the shape of an ergot kernel. The large ones, the big ones, are able to be removed or fall off into the field, which does make sense. But if we're looking at this from a host resistance, is the bigger the ergot body, we would often in plant pathology call that the more susceptible. But in a case of a cleaner, you probably want those because you know you're going to have a higher success rate of removing those from the grain lot. So we dove into ergot sclerotium characteristics, and the term that we came up with is logistical resistance, meaning that what were these varieties are able to have their ergot bodies more effectively removed than other varieties. And this is what we've done with the Vive analytics is here's an example of what would be considered a resistant variety on the left-hand side when it comes to doing the incidence. And on the right-hand side would be one that was susceptible, a higher level of ergot incidence on a spike. But notice the differences in these ergot body characteristics. We have some that are large and small, and sometimes it's difficult to predict. But not going to share the data because it does get complicated quickly, but there are some features in some of these varieties that have a tendency to produce longer sclerotia or ones that produce wider sclerotia or ones that tend to produce more sclerotia representing the seed of a kernel. And that's something that we're diving into more and that we're doing follow-up studies in the field. But again, it's a concept that was developed that when we think about this in plant pathology, it's just not, what we see from a host resistance. It's the aftermath too. It's what's being carried in a seed lot. And this is our approach to dive into the data a little bit more in future studies. So some of the summaries we found with our spring wheat variety resistance, nothing is immune. Our oldest variety, Walden wheat, still is what we consider the most susceptible. And where we weren't, we as in the breeders, the spring wheat breeders, were not increasing their ergot susceptibility or selecting for ergot susceptibility. So those are some very important messages. And then the final message is we did have some of the higher acreage varieties in the screening effort, and most of those are average or better for what we classified as ergot resistance. So that wasn't being what we call an over resounding cause of why we're seeing more ergots, because we were selecting for more susceptibility. The second question we've started in 2020 was evaluating fungicides for ergot suppression. When we started this effort, there was no labels that had ergot suppression on the label back in 2019. But as we conducted the study, two fungicides came on the market that were labeled as ergot suppression that are also labeled for Fusarium head blight. And so this more or less gave us a nice opportunity to say, what can we think of as ergot suppression when we already know most of our growers are spraying fungicides for our Fusarium head blight. So what this looked like is I'm summarizing data we've done in 2022 and 2023. We took three what I call popular Fusarium head blight products or standards in the market, Miravis Ace, Prosaro Pro, and Spherix. Since then, Miravis Ace and Prosaro Pro both have ergot suppression on their label. Spherix does not. But when we started this was more of an exploratory exercise to figure out, do we have anything that we're currently using as far as a Fusarium head blight application on the spike that can also have ergot suppression? The two timings we looked at is Feeks 10.3 or half head or full head Feeks 10.5. And the rationale behind this is I mentioned that the likely infection event that's occurring in our spring wheat is prior to flowering. It's at that pollination phase. So our target is to be able to be getting it on preventatively before the pathogen spores are able to infect. Our host for this now is it's difficult to conduct these trials with a conventional variety, but we were able to find some lines that were used in hybrid wheat, CMS or male sterile lines, meaning that they are very, very susceptible to ergot. So everything that I mentioned here was done on a CMS line, and it is extremely susceptible to ergot. And all this was funded by the North Dakota Wheat Commission. The things we looked at as far as data assessment, the grams of ergot bodies that we pulled from these plots and these small plots, and then we also ran ergot alkaloid analysis just to see if the fungicides were influencing that. Okay, what did we find across the 2 years? So on the vertical axis, you have the grams of ergot bodies that we were able to retrieve from these plots after harvesting and sifting and being able to collect them. It's a very laborious process. And on the bottom, we have our non-treated check, and then the three fungicides previously mentioned at the two different timings. So what did we find? Well, one thing that we found is that there was two products, product timings that did lower the amount of ergot bodies. And it was Miravis Ace at half head and at full head. And as far as Prosaro Pro and Spherix, we did not see a response in being able to lower the amount of ergot bodies in these plots. So yes, there is some suppression from a fungicide when applied for on the spike to reduce the amount of ergot, but it's not something that I think is controlled. So I think suppression is a good term and that we did see this multi years. if you go back to our data since 2019 to now on miravisates, it would suggest that it does provide some ergot suppression, at least when we tested it on this male sterile line. The second aspect we looked at was looking at alkaloids, so actually the toxic mycotoxin that are being produced. This took a little bit more creativity. We worked with the vet diagnostic lab at NDSU, and we were able to find an amount of ergot bodies in 80 grams of wheat, so 0.5 grams of ergot, not a lot of ergot, and 80 grams of wheat to be able to quantify the amount of alkaloids that were tested. Now, when it comes to testing for ergot alkaloids, there are 10 ergot alkaloids that are tested for, and what I am presenting is what is the total ergot alkaloid, so the summation of all those alkaloids into a value. And this is going to be in parts per billion. When we looked at those treatments, if you want to compare them to the non-treated check, we found that none of them were able to lower the ergot alkaloids, where 2 of them may start suggesting that they actually increase the amount of total ergot alkaloids. Now, this is from 2 years of data. We ran it again in 2024, still processing those samples. But the idea is that we know that we can reduce the ergot bodies, but we're not having an influence on the alkaloids that are present in those as well. So my last slide here is like, what do I think about this project? What do I think about ergot management? Well, I think right now ergot and alkaloid thresholds are likely to become stricter. If you look in the export market, there have been incidences of 0 tolerance for ergot. We see the European Union that are starting to move to a parts per billion scale to check their finalized or the food products intending for feed to human consumption. Everything's getting a little bit stricter with ergot. And so this is why it's important to understand these factors. Ways to reduce at least 1 ergot body is, can have a massive influence on what it can look like from an agronomic potential. So we have the tools in place. Some of them is what I call very traditional, and some that we're still exploring to see if there is a use, such as fungicides. But the idea is that, yes, this is going to be a reoccurring issue, and it's something that's going to be brought up, and especially when it comes to the export market. The other arena that's starting to expand is hybrid wheat, and which is a great, it's a great technology used and it's being implemented. But when it comes to seed production of hybrid wheat, when you have an A line and a B line, or basically a male sterile line, which we use as a universal susceptible, ergot is one pathogen that has a drastic effect on seed set, or the amount of seed that can be from a field. So some of this fungicide data that we're using has been used by some of these hybrid wheat industry to help just achieve a little bit more seed that they can use to release a hybrid wheat variety. Finally, we have to be aware that, at some point it's possible, hypothetical, that we may be shifting away from a visual inspection and it might go to a quantitative assessment of parts per billion. Now, the thing I worry about is in a parts per billion, that's extremely sensitive to any type of shaving or a crack or a sliver of an ergot body. So some of these challenges I think down the road that we're going to have to get in front of are there. But the good thing is that we know we have management tools in place. We can incorporate those management tools, and we can at least start the conversations. And some of it might be just as easy as crop rotation, taking care of those field edges, or just having a harvest strategy to avoid commingling of those lots. Some final thoughts. We know it's going to be a common disease. It's been here. It's not just a US, it's up in Canada. We've had these conversations with our colleagues. We're going to continue these managing efforts. And again, implementing these type of resources like today to the growers to answer some of those questions is going to be one of our most important concepts. I would like to thank my extension crew, starting with Leanne Lux when she was here as a graduate student, Jessica Halverson and Brian Hansen that helped with this. And then the North Dakota Wheat Commission for funding, the Crop Protection Network for being able to let me speak today, and the NDSU Vet Diagnostic Lab for some of that ergot alkaloids. Again, thank you for your attention. If you have any questions for me, you can reach out. Googling me, Andrew Friskop, is probably the best way to get some of my information if you have any more follow-up questions.